Hi everyone. So this series of lectures covers trigonometry, and I'm going to be explaining the basic rules behind it. In this video we're going to be looking at the purpose of trigonometry, and we're going to learn its basic rules and the basic foundations. I think if you're going to study trigonometry, it's worth learning, revisiting these topics: the Pythagoras' theorem, that angles in a triangle add up to 180 degrees, rearranging formulae, multiplying, dividing fractions, and reciprocals. So what I mean by reciprocal is if I have A over B, the reciprocal of that is B over A. When I multiply those two together, look what happens, they cancel out, and I'm left with 1. So a rule is that reciprocals always multiply to give you 1. Say for example, if I had 3/4, and I multiply that by 4 over 3, look what happens, it cancels out to give me 1. So trigonometry, we can break it down into two words: trigonon, which means triangle, and metron means to measure. So it's about measuring the side lengths and angles of triangles and the relationship between them. We use it in constructing buildings. As you can see, all these shapes are made up of triangles. And the triangle is a fairly stable shape compared to the square. That's why we like to use it. We also use it for modelling forces, so not all forces go up and down. Some of them go diagonal. For example, this force here, 7 newtons, it's having a horizontal effect to the right, but it's also having a vertical effect. So what we essentially have is a triangle, right angle triangle, where 7 newtons is the hypotenuse. But what the physicists need to work out is what is the length of this side, what is the horizontal force, and what is the vertical force. And that's where trigonometry comes in. So we can work these out if we know the angle. But we're going to come on to that in more detail. So I think, first of all, a good exercise is to pause this video and tell me anything you know about these triangles. And then once you've done that, start playing the video again. Okay, so let's explore it a bit more detail. So as we can see, these two are right angle triangles. And some of you might have realised that AC is 5 centimeters and DF is 10 centimeters. So we have a multiply by 2 to give you that, multiply by 2 to give you that, and multiply by 2 to give you that. So what we essentially have is we know that the ratio is a 3:4:5 ratio for both of them. So we know already that the ratio of the sides is the same, but what else do you think is the same? So if I had an equilateral triangle, we can tell that we know that the angles are going to be the same. So one rule is that if the sides are the same, if the ratio of sides is the same, then the angles are going to be the same. Let's see how this applies here. Well, think about if we're going from point D to point F, and I'm going to draw a point here. Right? If I can either go from D to F this way, or I can go 6 down, 8 across. Another way I can go is if I go 3 down, 4 across, or 3 down, 4 across. Okay? Now, to show you I've modelled the situation correctly, so in other words, basically, we have a right angle triangle here, we have a right angle triangle here. What this means is that if you think about it, the 4 and the 3 are here, and this angle is going to be the same as this angle. If we think about this, if I told you that A was 10, which it isn't, what would C equal to? Well, C would equal to 80. So we would know that these two angles add up to 90 degrees. So I'm going to cancel that out, and instead I'm going to put C is equal to 90 minus A. So therefore follows, if D is equal to A, or D then C is equal to F. And obviously we know B and E are the same. It's the same ratio of sides, same angles. And I can also prove to you that this is correct, because the area of this is 6. The area of DEF, we should be getting base times height over 2. So we should be getting 6 times 8 over 2, and that gives us 24. So if I've done this situation correctly, then we should be getting 24. Well, let's see if we have. So if I do, the area of this triangle is 6, the area of this triangle is 6, and the area of this rectangle is 12. And we get 12 plus 6 is 24. Well, I can put centimeters squared, and therefore I've shown to you that I've modelled the situation correctly. So trigonometry is essentially the missing link. It tells us if we know the ratio of sides in a triangle, we can work out the angles, and if we know the angles in a triangle, we can work out the ratio of sides. And we start off with right angle triangles because we know at least one angle is 90 degrees. Now let's look at, we have to understand some terminology before we actually approach the basic principles. So which side do you think is opposite to angle A? Well, I've got angle A here, and it's going to be BC. And the reason for that is BC is not touching. It's the only side not touching A, and that's how you know it. Fairly straightforward. So this is my opposite side. Let's try another one. Which side is opposite to angle F? So we have angle F here. Which side is not touching? It's going to be DE. Because it's not touching. I also want to point out as well that the 5 centimeters is the hypotenuse, so which is opposite the right angle. Okay, now we've asked which side is adjacent to angle A, so I'm going to label this side opposite to A. Which side is adjacent and why? Well, we know this is the hypotenuse, so it's the adjacent side has to be this one. And why is it adjacent? It's touching A, but it's also touching the right angle, or 90 degrees. So it can't be the hypotenuse ever. Okay, let's try another one. Which side are adjacent? Also, I wanted to point out as well, opposite to angle A is adjacent to angle C as well. And adjacent to angle A, what is that going to be opposite to? Opposite to C. We're going to explain the significance of this. Another way of writing C is 90 minus A. So opposite to angle A is adjacent to 90 minus A, and adjacent to A is opposite to 90 minus A. We'll explain the significance of this later on. Okay, let's try another one, adjacent to angle F. Okay, so we've got angle F here. Which one's adjacent? It's going to be EF. Boom. Because it's touching the right angle, and it's touching the angle. And EF is also opposite to D. Now, as I said, trigonometry is a study of ratios, and these are three key ratios that we look at. But to understand these ratios, let's do this let's have a look at, do a bit of an investigation. Let's look at what these ratios are for these two angles. So we have angle A of A degrees and angle D. Okay, what can you tell me about angle A and angle D that we covered? Well, they're the same size, aren't they? Okay, so angle A, as we know, angle A, so opposite, we already figured out. Hypotenuse we have here, so we have 4/5. Okay, angle D, opposite we have here, hypotenuse. What does that give us? That gives us 8/10. And 8/10 is an equivalent fraction to 4/5, because if you think about it, you times by 2, you times by 2. Let's see what we get for adjacent over hypotenuse. So I'm going to put adjacent here. We get 3/5, because adjacent over hypotenuse, and then our adjacent here, touching D, is 6. So I'm going to put 6 over hypotenuse is 10. So times by 2, if you think of it, they're equivalent fractions. So the 6/10 we can cancel down into 3/5. Opposite over adjacent, let's try this one. So opposite over adjacent, we're going to get 4/3. And we're going to get, for D, we're going to get 8/6. So what can you tell me? So these are equivalent fractions. So what that means is that if same-sized angles have the same ratios, so obviously these two were the same size, and we saw that the ratios are exactly the same. So ratios are same. And therefore it follows that if we know the angle of a triangle, we can work out using trigonometry, each angle will be associated with a specific set of ratios. So opposite over adjacent will be the same, adjacent over hypotenuse will be the same, and opposite over adjacent. A good example of this is 30 degrees. I always know that my opposite over hypotenuse is going to be a half, but we're going to explore that in more detail. So as I said, opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent are unique for a given angle less than 90 degrees. And another word for sine, for opposite over hypotenuse, is sine. So SOH, S-O-H, I remember it by. Cosine is adjacent over hypotenuse, so cosine of an angle is adjacent over hypotenuse. And tan of an angle is TOA. Okay, so let's go through how these are used. So I'm going to put SOH, this is a better slide, so I'm going to put SOH CAH TOA, and we're going to see how these ratios work. So I told you already, we already know that opposite over hypotenuse was 4/5 for A. We're using angle A, by the way, which we used last time, same triangle, 4/5, 3/5, 4/3. Now let's see how this works. So sine of an angle is equal to 4/5. So if we have A here, opposite was here, hypotenuse, so we've got 4/5. Cosine of angle, we can write cos A. So these are abbreviations. Cos A equals 3/5. So again, we're using the same angle. Example 1, angle A. Then we can say tan A is equal to 4/3. Now, if you remember in the previous slides, we discussed that angle C has a value of 90 minus A, because both angles have to add up to 90 degrees. I can also show you down below if you're not convinced. A plus 90 minus A is equal to 90 degrees. And 90 plus 90 degrees gives us 180. Okay, so let's have a look at how the trigonometric ratios apply to angle C. So, okay, what side is opposite to angle C? It's the AB, or 3 centimeters. So I'm going to say 3 over 5. Okay, what's adjacent? I'm going to put the 5 at the bottom because you already know what that is. Adjacent is touching the C is the 4 centimeters. So I'm going to put 4 here. And tan of an angle is opposite over adjacent. So opposite was 3, adjacent was 4, so I'm going to put 3 over 4. Now let's have a look at what relationships we notice. So I think I always like to, when I'm doing maths, I always like to work out what relationships I can find. So let's do the first one. What are the relations? Which ones are giving us the same values? Well, if we think about it, sine of an angle and this one are giving us exactly the same values. Okay, why is that? Well, let's have a think about it here. This is going to give me some additional rules. Why is it not coming? There we go. So if we think about it, opposite to A is 4, but that's also adjacent. This 4 is adjacent to 90 minus A. Okay? And adjacent to 90 minus A is opposite to A, or opposite to 90 minus A. What's that going to be equal to? Adjacent to A. So what I'm trying to show you here is that one man's opposite is another man's adjacent. Okay, so let's see how this works. So we know that sine A equals 4 over 5 equals cos A. So the 4 centimeters is adjacent to A, opposite to A, but adjacent to 90 minus A. So I'm going to write sine A equals cos 90 minus A, because we know they're the same. And okay, so an example of this is if I have sine 10 degrees, that's going to be the same as cos 80. Or if I have sine 15, let's do sine 20, that's an easier one. It's going to be the same as cos 70. Okay? Now let's see what else is the same. So I'm just going to put my highlighter on, and I'm going to go to green. If we have cos A here, and if we have, we know these two are the same now. So what's special about this? Well, I'm just going to put on my pen, and yep. So as we can see, again, this is opposite to 90 minus A, and this is adjacent to A. Opposite to 90 minus A and adjacent to A, so I'm just going to highlight the rule that we did together just to show you visually. So opposite to 90 minus A, adjacent to A. Let me just colour in the other one whilst we're here. Opposite to A equals adjacent to 90 minus A. So I'm just going to colour that in. So we know therefore that cos A equals to sine 90 minus A. So again, this time we can think of it as cos 10 equals to sine 80. These are just examples of random angles. So cos 10 equals sine 80 and cos 20 equals sine 70. Now, you don't really need to know this, but I'm just showing you that these relationships exist, and I thought it was quite interesting. Okay. Now, here's another one you might have noticed. Okay. What's 8/5 divided by 4/5? Well, we can tell that 2 is going to be twice, but I'm going to show you anyway. I'm going to show you that 8/5 times 5/4 is going to give me, if I cancel this out, it's going to give me 8/4, which gives me 2. But here's a quicker way we could have done all of this and avoided us. We could have just cancelled out the denominators, and 8/4 gives us 2. In the same way, we can do this way. We can cancel out because their denominators are the same, we can just cancel them out. So we get opposite over adjacent. Okay? Oh look, opposite over hypotenuse divided by adjacent over hypotenuse equals opposite over adjacent. What's another word for... I'm just going to write it out again so that you can see. Okay, so what's opposite over hypotenuse? We can say that's the same, we can call that sine A. What's adjacent over hypotenuse? That we can call that cos A. So sine A divided by cos A, what's that going to give us? What angle here deals with opposite over adjacent? Tan A. So an example is, if I had sine 30 degrees and I divided by cos 30, guess what I'm going to get? I'm going to get tan 30. Okay? So you see there are all these rules that are tricks. It's not just these 3 rules, we actually have 6 rules. Well, there are actually more rules, but I'm only sticking to 6 just for the purposes. So, okay, so what do you notice about tan A and tan 90 minus A? What do you notice about tan A and tan 90 minus A? Well, if you think about it, one is the reciprocal of the other. And why is that? Well, because we're doing opposite here, and the opposite is coming to the bottom, and we have the adjacent here, and the adjacent's coming to the bottom. Okay, now remember what we did before when we were multiplying by reciprocals? We did 7/5. We knew the reciprocal multiplied by itself gives us 1. I'm going to prove that to you. So if I have 7/5 times 5/7, the 5's cancel out, the 7's cancel out, so you're left with 1. In the same way, if we're doing, that should be opposite. In the same way, if we're doing opposite over adjacent times by adjacent over opposite, what's that going to give us? That's going to give us 1 as well. So another rule we can have is tan A times by tan 90 minus A equals to 1. So as you can see, 4/3 times 3/4 equals 2. Cancel out, and we're left with 1. An example of this, let's say if we have tan 10 times by tan 20 tan 80. That's going to give us 1. Okay? Great. So I think we have 4 rules. So, you know, the sine A equals cos 90 minus A, cos A equals sine 90 minus A. You know, I mean, these two are the same, basically. We have the sine A over cos A equals tan A. And we have tan A times tan 90 minus A equals 1. So what I'm saying is that all these relationships exist. Before we're going to show how to rearrange formulae, but here's one thing I want to show you. Let's use sine as an example, which is opposite over hypotenuse. Basically, what it's telling me is if I have a 30-degree angle, it's telling me if I know my angle size, what's my opposite over hypotenuse. So, for example, if I have 30 degrees, if I put it into the calculator, so I do sine 30 degrees, as I've done here in Google, I get 0.5. And what does this mean? Well, it means that opposite over hypotenuse is equal to a half, or 0.5. Let's apply it to here. So opposite over hypotenuse for the 30-degree angle, if I was trying to find the length of BC, well, here's a quick way of thinking about it. 20 is the hypotenuse, BC is the opposite, and we know that the opposite over hypotenuse is equal to half. So if I have x over 20 equals to a half, what do you think x is equal to? Well, if I go times by 10, times by 10, x is equal to 10 centimeters. So in other words, what this ratio is saying is that for a 30-degree angle, my hypotenuse is double my opposite side. Okay, that concludes this presentation. The next one we're going to move on to looking at how to rearrange the formulae. Thanks everybody, have a great day.